All right, we're going to continue. I'm going to go back into 4-5. So you learned how to complete the square in the first part of 4-5. I just want to show you a couple of examples, a couple other ways you might see it. One way that's going to use imaginary solutions. So it's going to tie into what you learned in 4-4. And then one way how to complete the square when A is not 1. And so there's not a ton of times that you're going to have to complete the square, but it is nice if you recognize a pattern. So make sure you get 4 or 5, the first part of those notes written down. And this is just kind of a little bit of an add-on to that. And I'm actually going to do these out of order from the book. I'm on page 259. And I'm going to be in example 6 first. And so we're going to go solve x squared plus 8x plus 22 equals 0. Now, and I've given you the green light on solving these things, graphing them and finding the x-intercepts or the roots. That's not going to happen here. If you go put this in Desmos or if you put it in your TI calculator, you are not going to see any roots because there's not any real roots. They don't cross the x-axis. So we've got to have another way to solve this. Now, this is leading to, and probably the best or the way that I would recommend the most, is quadratic formula. But we're not there yet. We haven't learned quadratic formula. That's in the next section. So what we got to do is we're going to look at how completing the square can help us solve an imaginary and find imaginary solutions. We're still looking for 2 solutions because it's quadratic. So we're going to complete the square to do that. So it's the same steps in what you learned in the first part of this. All right. I want to move 22 to the other side. It's not a perfect square, so I want to move it. I'm going to make there be a perfect square there. So this is going to be x squared plus 8x. Leave yourself a blank. I moved 22 over, so it becomes negative 22, and I'm putting a blank. And so now we make this a perfect square trinomial by doing the following little formula. B divided by 2 squared. Remember, B is the number in front of x. We're going to divide it by 2, square it, and put it back in. So the first part of your binomial factor that's going to be the same is x. I divide 8 by 2, so that's positive 4. We put it there. And then I square 4. 4 times 4 is positive 16, and I put it there. If I put it in my left blank, I put it in my right blank. So x squared plus 8x plus 16 breaks down to x plus 4 squared. It's x plus 4 times x plus 4. Now we do the math on the other side. Negative 22 plus 16 is negative 6. All right, just as you learned in completing the square, now we're going to go get x by itself by taking the square root of both sides. And you see something happen. Okay, left side is pretty normal for what we've been working. The square root of x plus 4 squared is x plus 4. A square root and a squared pretty much cancel each other out. On this side, remember, we've got 2 answers, plus or minus, but now I have the square root of negative 6. You learned when you started dealing with complex numbers that we're not going to have the negative stay inside the radical. We're going to make it an imaginary unit and pull it out. So let's go ahead and do that. So I've got x plus 4 equals plus or minus I radical 6. I pull the I out front. Now, what we've learned is breaking down the square root of 6, well, it's got to have a perfect square factor to do that, and it doesn't. 1 times 6, 2 times 3, 1 is a perfect square. It doesn't do anything for us, right? So we're right here. And I'm actually pretty close to being ready to write this. I now need to subtract 4 from both sides. Now, when I do this, understand where it goes. It goes in front of the plus or minus. So x equals negative 4 plus or minus I radical 6. That's your answer. Those are the 2 roots. They're just imaginary roots. Now, you've got to know one root is negative 4 plus I radical 6. One root is negative 4 minus I radical 6. The solution set is written right there in example 6 for you to see that. I'm fine with you leaving it like this. Okay? Just understand and connect that. It may look like this, or it may look like it does in the book. Page 259 right there. Okay? So that's stuff that you can do. Now, I want to show you what happens and how this works if you get a number in front of x squared that's not 1. Okay? It's not 1. So I'm backtracking, and we're going to example 5. So we're going to do this. 2x squared minus 7x plus 5 equals 0. We're going to solve this by completing the square. Now, this is not going to have imaginary solutions. So this is something you could just do in Desmos or your TI calculator and find the roots. But I want to show you how to complete the square when, in this instance, A is greater than 1. It's just if A isn't equal to 1, here's what we're going to do. We're going to divide everything by 2. So technically, I'm going to divide the whole problem by 2, even the 0. Divide by 2, divide by 2, divide by 2. Okay? So this divided by 2 just gives me x squared. Now this is negative 7 halves x. Yeah, it's a fraction. It's okay. Leave it there. This is plus 5 halves. That's fine. And then 0 divided by 2 is still 0, so that kind of cleans up. So we're going to follow our completing the square steps. This isn't a perfect square, so I'm going to move it. So I've got x squared minus 7 halves x. Put my blank. I subtract negative 5 halves over. I put my blank. Now when we go divide by 2 right here, so remember our steps, we're going to get a perfect square trinomial by doing b divided by 2 and squaring it. So the first term is obviously going to be x. This divided by 2 becomes negative 7 fourths. If you're not good at that, do negative 7 halves in parentheses in the calculator divided by 2. Okay, just so you know, when you divide by 2, that's a denominator, right? So when we do that, it goes with the denominator that's there. That's how we get negative 7 fourths. Now we're going to square this and put it back. How do I square a fraction? You square both the top and the bottom, or both the numerator and denominator. Now, whenever you do this, this is always going to be positive because a negative times a negative gets a positive. So when you complete the square and you plug it back in, you're always going to get a positive answer. All right, 7 squared is 49. 4 squared is 16. So I'm going to add 49 over 16. And I'm going to put that on both sides, plus 49 over 16. Now we got some math to do over here. I got negative 5 halves plus 49 over 16. So you got some ways that you can do this. You can do it by hand. You can go get a common denominator. You can turn this into 16. You can multiply that by 8, right? That's not hard. Let's let the calculator work for us. That's its job, right? That's what we got these sweet TI calculators for. All right, so here we go. Negative 5 divided by 2. Remember when you put fractions in, put them in parentheses. Plus 49 divided by 16. Get your answer. Math, enter, enter. There you go. See it? 9 over 16. So this is 9/16 over there. Just use a calculator. Pretty simple stuff. I don't mind if you do it by hand. Do it right. All right, we're at the same step here. Let's go solve. How do we get x by itself here? The whole thing was squared, so I'm going to square root both sides. So I have x minus 7 fourths. Yes? Now over here, I've still got my plus or minus answer, but this actually cleans up. Coach, how do you take the square root of a fraction? You take the square root of the numerator, and you take the square root of the denominator. They're both perfect squares here. So it works out nice. The square root of the numerator is 3. The square root of the denominator is 4. So the square root of 9/16 is just 3/4. Now remember, it's plus or minus 3/4, so we got 2 answers because we took the square root of this squared answer over here. So I'm going to have 2 answers. So now what I really have, I'm now going to add 7/4 to both sides. Okay? So I'm here. X equals 7/4 plus or minus 3/4. Now we're ready to split it up and get our answer. Okay? So I'm going to split it up over here. X equals 7/4 plus 3/4. Over here, x equals 7/4 minus 3/4. If you're not good at that math, do it in the calculator. But these aren't hard. They're already common denominators. Remember, when you have a common denominator, add numerators here. 7 plus 3 is 10. The common denominator is 4. Can we clean that up? You bet. That reduces to 5 halves. That's 2.5. Over here, I get x equals, what's 7 minus 3? That's 4 over 4. Does that clean up? Dang right. Cleans up to 1. There's your 2 roots. X equals 5 halves. X equals 1. So you can use completing the square to solve this, okay? Just wanted to show you what happens when A isn't 1. Something that you can add into your notes, kind of part 2 of completing the square. And it's crazy. This is getting you through Thanksgiving. We'll come back after Thanksgiving break, and we'll attack the quadratic formula. Appreciate you listening. If you have any questions, please come ask. Make sure when you do it, bring your notes so that I can walk you back through what I've done, and we can get you moving on your assignments. Thanks.